Here question is analyze the frame using for portal frame method. So we know portal frame method is used to analyze the frame subjected to lateral loads. Here the height of the column is 4 meter, width of the length of the beam, that is BE equal to 3 meter, EH equal to 2 meter, HK equal to 3 meter. So the load acting are 60 kilonewton at the top floor and also at the bottom floor. 60 kilonewton load is acting. So in the portal frame methods, first of all you had to find this column shear, then you had to find these column moments, then you had to find these beam moments, then you had to find this beam shear, and finally column axial forces. Then draw the bending moment diagrams of both beams and columns. So first of all we had to find this beam shear. So in the portal frame method, it is assumed that the column horizontal shear in the interior column is 2 times that of the column shear in the exterior column. Suppose if this is P1, in the interior it is 2P1. Similarly, if it is this is P2, then in the interior it is 2P2. So first of all find out this P1 and P2 values. For that consider a section. In order to find P1, consider a section at the midpoint of the upper column and consider the upper portion and apply equations of static equilibrium, that is sigma Fx equal to 0 implies 60 equal to P1 plus 2P1 plus 2P1 plus P1. Then you will get the answer 6P1 equal to 60, P1 equal to 10 kilonewton, 2P1 equal to 20 kilonewton. That is force in the interior columns, horizontal shear in the interior column is 20 kilonewton and exterior column is 10 kilonewton. Similarly, find the P2 value. For that consider a section passing through the midpoint of the first floor columns. Then consider its upper equilibrium of the upper part and apply static equilibrium equations, that is sigma Fx equal to 0 implies 60 plus 60 equal to P2 plus 2P2 plus 2P2 plus P2. That means 6P2 equal to 120 kilonewton, P2 equal to 20 kilonewton, therefore 2P2 equal to 40 kilonewton. Next we had to find these column moments. Here I am finding these value from the picture itself. So for that first of all mark all the column shear in each columns. Now find the column moments, that is with respect to this point, with respect to this point, with respect to this point, this moment due to this force is sagging. So here this column moments at this end is sagging and the value is 10 into 2. That means this length is 2. Therefore the moment at this point at this end is 10 into 2 and it is sagging. Therefore I can write this value as 20. So this is 10 into 2, that is 20. Similarly same value here, this is sagging, this condition is hawking. Similarly find at this end, I can write this column and these are also sagging with respect to F. This moment of force 20 kilonewton, that is equal to 20 into 2 and also it is sagging, and write the value 40. So here also value is 40. Similarly here also value is 40 and here also value is 40. Similarly here 10 into 2, that is 20, here also 20. Now consider the first floor, this is 20 and this half the length height of the column, that is 2 meter, 4 by 2, 2 meter. Therefore this moment value is 40, this value is 40. Here 40 into 2, half the height of the column, that is 40 into 2, that is equal to 80. Similarly here also 80, here 80, here also 80, here 20 into 2, 40, here also 40, 20 into 2, 40, and mark all these moments in this figure. Next, therefore in general I can write this column moments equal to I can write column moments equal to column shear into half the height of the column, half the height of column. Now next find out the beam moments. So here I have marked all the column moments here. So from this figure we can find beam moments, that is here we are using principle, that is sum of all the beam moments should be equal to sum of all the column moments. Beam moments equal to sum of all the column moments. Therefore I can find this column moments, that means here beam this column moments is 20 kilonewton, so the corresponding beam moments is 20 kilonewton and it is in reverse direction. That means sum of all beam moments should be equal to column moments. So if 20 here the column moments is 20 kilonewton anti-clockwise, so this moment in clockwise direction and the value is 20. Same value is here also 20. So here also we had to satisfy that condition. Sum of all the beam moments should be equal to sum of all the column moments. So here the column moment is 40 in anti-clockwise direction. Therefore here and this is beam moments in clockwise direction. So in order to make moment at the at this joint 0, we had to add a beam moment 20 here. So 20 plus 20 minus 40 equal to 0. Therefore here also same 20 moment is there. Same I had to add also here also 20. Therefore 20 plus 20 minus 40 equal to 0. Here 20 kilonewton force, therefore it is also 20. Same moments. Similarly here I had to make all the moments, net moments at the joints 0, or sum of all the column moments should be equal to sum of all the beam moments. So here total column moments is 60. Therefore this value is 60. Same value is at this end also. Therefore here also sum of all the column moments should be equal to sum of all the beam moments. So this is total 120. Therefore this one also 60. Therefore I can write this 60 plus 60 plus 60 minus 40 minus 80, that is equal to net moment equal to 0, or sum of all the column moments, that is 120 equal to beam moments, that is 120. Same 60 is also here. So here also the value is 60. So this is 60 plus 60 minus 40 minus 80 equal to 0. And at this junction also 40, 20 is the total column moments. Therefore here also value is same. Okay, at both ends of the beam the moments are same. Okay, now let's From the beam moments, find the value of beam shear. Okay. So here equation is beam shear equal to here the equation is beam shear equal to beam moment divided by half of the span length of the beam. That is, this is the equation. So here I am marking all the values of beam moments. Then this value you will get, that's equal to 20 divided by total length is 3 meter. So 20 divided by 3 by 2, that is equal to 13.33. Here this value is 20 division 3 by 2. Therefore that value is 13.33. Similarly, this value is, here the total span length is 2 meter. So this value equal to 20 divided by 2 by 2. That is 20. Similarly here also 13.33. 20 divided by 3 by 2. Similarly here 60 divided by 1.5. Here the value is 60 divided by 3 by 2. That is 1.5. Same value is here 60 divided by 2 by 2, that is equal to 1. Here 60 divided by 3 by 2, that is equal to 1.5. Next, find the from the beam shear, find the axial force. Here the condition is total upward force equal to total downward force. At the junction, sum of all the upward forces should be equal to sum of all the downward forces, or sigma Fy equal to 0. So this beam shear is 13.33. So at this junction, the axial force in the column is 13.33. Similarly, if I take this section, here 13.33 downward, here 20 kilonewton beam shear upward. So total upward force should be equal to total downward force. Therefore I had to add 6.67 kilonewton downward in the column. That is 13.33 plus 6.67 plus 20 equal to 0. That is, I am considering this figure. Okay, so total upward force should be equal to total downward force. Similarly, next consider this one, that is this section, this joint I. Also apply the same condition. Then you will get here the value 6.67 upward. Here these first two columns are the axial force in the first two columns are in tensile in nature. Then axial force in the last two columns are in compressive in nature. That is, here the centroid of this section, this frame comes in this here around at this point, centroid of the section is coming. So in the left side of the section, that is all the column axial force is in tension in nature, and right side is all the force in compressive in nature. Similarly, we can find this axial force value in the first floor is greater than that of second floor. Okay, so axial force value is increasing when it is come down. Okay, so in the first floor it is maximum. Similarly, in the exterior column is maximum. Axial force in the column, in the exterior column, is higher than that of the axial force in the interior columns. Okay, so if I consider this section B, I can found this axial force, that is this value is 13.33 upward and this is 40 kilonewton upward. So in order to make 0, I had to add 53.33 in downward direction. So here satisfy the condition sigma Fy equal to 0. Similarly, here also this is 6.67 and this is 40 downward. Here the values are 40 here, the 40 kilonewton beam shear downward, 6.67 column axial force upward, 26.60 kilonewton beam shear upward. So total upward force should be equal to total downward force. Therefore 66.67 minus 40 minus 26.67, that is equal to 0. Similarly here also, next, and find by this way find all the column axial forces. Next, mark all these values. You can in exam you can show all these without any steps. If you know how to calculate these column shear, column moments from the figure itself, you can mark all these things in one figure. Okay, ഒറ്റ ഫിഗറിൽ മാത്രം മാർക്ക് ചെയ്ത് കാണിച്ചാലും മതി. ഇത്രയും സ്റ്റെപ്സ് തന്നെ ആഡ് ചെയ്യേണ്ട ആവശ്യം ഇല്ല. ഈ ഒരൊറ്റ ഫിഗർ വെച്ചിട്ട് തന്നെ നമുക്കിവിടെ മാർക്ക് ചെയ്യാൻ പറ്റും. സോ ഹിയർ നമുക്കറിയാം വാല്യൂസ് ഈസ്, മാർക്ക് ചെയ്താൽ കിട്ടുന്ന വാല്യൂസ് എന്ന് പറഞ്ഞാൽ values are here എത്ര വരുന്നത്, the value is we know column shear value. First of all, mark all the column shear values, that is 10 10 20 20 10 20 40 40 10. Okay, so here you can mark. From this figure you can find all these values. First of all, you have to start from column shear. So the value is here 10, here also here 20. Now this is 10 20, then this is 10. Similarly this value is 20, this value is 40, this value is 40 and this value is 20. Now you can find this moment, column moments, that is this value is 10 into 2 20, here also 20, here 40, here 40, here 40, here also value 40, here 20, here 20, and also here the column moments value is 20 into 2, that is 40, here also 40, here 80, here also 80, here 80, here also 80, that is 40 into 2. Similarly here 20 into 2 40, here also you can mark 40. Now you had to find this beam moment. So all the column moments should be equal to all the beam moments. Therefore it is 20. So same values here 20. So 20 plus 20 minus 40 equal to 0. Same value 20 here. So here also 20 plus 20 minus 40 equal to 0. Here also 20. Similarly here 20 40. Therefore this value is 60. Okay. So this value also 60. So here 40 plus 80, 20, 120. Therefore this is 60 and this also 60. Here also value is 60. Here also here the value is 60. Here this is 120. Therefore this is 60 plus 60. Same value is also here 60. Now after that you had to find this beam shear, that is 20 divided by this value is 3 meter. Length of the column BE is 3 meter. So this value is 13.33. 20 divided by 3 by 2 and this value is 20. Same, this value is 13.33. Now this 60 divided by 3 by 2, that is 60 divided by 1.5, that is equal to 15. Sorry, 60 divided by 1.5, that is equal to 40. Okay, here value is 40. Here also value is value 60. 60 divided by 2 by 2, that is equal to 60. Here value is 40. Now after that find this column axial force. This is 13.33 upward. So here also value 13.33 downward. Same value is here 13.33 downward. So here the value is 20. This is 13.33. So here I had to add 6.67 in downward. So 13.33 plus 6.67 minus 20 equal to 0. Okay, so same value similarly here this is 20 in downward direction, this is 13.33 upward direction. So in order to make sigma fy satisfy this condition, sigma fy equal to 0, I had to add 6.67 in upward direction. This value is 13.33 in upward direction. Okay, similarly here 13.33, this is at the junction B. Here the column axial force is 13.33 upward, here 40 upward. So here I had to add 53.33 downward. Same value is also here 53.33. Here the column axial load is 40 downward and this is 60 upward and this is this value is also here, the value is 6.67 upward, here 6.67 downward, here 13.33 downward. So here this is 40 downward, 6.67 upward, 60 upward. So 66.67. Therefore here the value is 26.67. Same value is also here 26.67. And here also value is 60 downward, 40 upward, 6.67 downward. So the value is 26.67 upward. Same value is also here 26.67 upward. Here 40 downward, 13.33 downward. So the value is 53.33 upward. So after that you had to draw this bending moment diagram and bending moment diagram of both columns and beams. So first of all draw the figure. It is 3 by 2 story. So for the beam moments, that is here, this is beam moments, beam moment, Bending moment diagram of beam moments. So we know the value are here 20 kilonewton, that is sagging, here 20 kilonewton hogging. So we draw like this values. So here this is sagging, so at the supports draw the sagging moments inside the beam. Okay, and this value is positive. This value is positive, and this value is, here the value is negative, and value is 20. Here also value, same value 20. Now draw the bending moment, beam moment for the second beam. So point of contraflexure occurs at the middle point, therefore at the midpoint bending moment is 0. So this value also positive. This value is, we know the beam moments value here also 20. So this is positive and value mark here 20. Similarly this is negative and mark the value 20. Similarly draw other. So here it is plus. This is also sagging. This is minus. This is positive. Okay, and the value is same 20.